Gentlemen, please welcome Ted Czarnecki, Pfizer, and Rafi Zvi, CEO, BackBox.
Good afternoon, everybody. Ted, thank you for being here with me. Wow, I've never done this. That is just too scary. I feel like I'm Beyonce right now. But don't worry, I'm not going to take my clothes off. Thank you, everybody, for being here. Good afternoon. Thank you, Ted, for joining me on stage. Thank you, Check Point, for having us. We're going to take the next few minutes to share, Ted and myself, our experiences around intelligent automation with BackBox. We've been a longtime partner of Check Point. We've been doing this show for 6 or 7 years. And since we're really short on time, those of you that joined our breakout session, so this is going to be a little bit shorter, we're going to go through some of the capabilities that will help you better maintain and manage your security infrastructure, specifically with Check Point, and your entire infrastructure as far as security and network devices are concerned. So taking you back a little bit far, around 6 or 7 years ago when we started with BackBox, we wanted to help our customers face and deal with some of the challenges that they have in their security environments. And the first challenge that our customers had was around disaster recovery procedures. So how do we make sure that we are able to very quickly and efficiently resolve any hardware or software issues that are causing downtime? So in our early versions, our focus was around backup and recovery. And to this day, we're expanding those capabilities around disaster recovery, helping organizations very quickly collect the information in an automated manner, collecting all the configuration files required for a full disaster recovery. On top of that, during that process, we're making sure that both the files are securely stored in the network and that the files are encrypted. So in case anybody gains access to those files and those configuration files are not compromised. We wouldn't want anybody tampering with our security policy if we ever need to recover those configurations. So we have offered since the beginning both an automated way of backing up the configurations and an automatic way of recovering in case of a failure. So this means that if at any point something happens to any of our devices on the network and we need to replace it, we can now very quickly, by an automated process where BackBox will collect those files, make sure that their integrity is still intact, make sure that they're not tampered with, and with a single click, allow us to recover that device and bring it to the same state that it was before it failed. So that was phase one. And then we started talking to all our customers that have been using the disaster recovery solution and asked them, what else do you need? What else is currently done manually and we can help you automate? So the next phase for that was asset management. How do we make sure that we are in full awareness of all the assets, security and network devices that we have? So the next capability that we added is an automatic way and a dynamic way of collecting asset information. So this could be anything from the IP addresses of the devices, the platforms that they're running on, the type of UTM, the versions, major, minor, patches, etc., and also the license information. This gives us the ability to first eliminate those static Excel files that a lot of customers use in order to keep track of the assets, and secondly, help us better plan. So for example, if we ever needed to upgrade our security platform, we want to make sure that both on a software level and on a hardware level, those upgrades are possible. So we want to make sure that our device, our UTM, will actually support the new version. And we want to make sure that the upgrade process is supported on a software level. So can we go from our 7.30 to our 80.20 in a single hop? So with this asset management, we now have the ability to get a single view of all the assets we have on the network, all the versions, and understand both end of sale, end of support, and upgrade paths that we can accomplish on our environment. So this was eliminating Excel. I don't want to talk too much about Microsoft, but the next software we wanted to kind of play around is Visio from Microsoft. A lot of organizations use Visio in order to create their network diagrams. The limitation there is obviously it's static information. Every new device you add to the network, you have to manually add it. And then it's still a static sheet, right? And there's only so many objects you can fit. Since we are already connecting to all our devices, and since we already have the credential information, BackBox has now the ability to automatically draw out our network map. So give us a dynamic illustration of what all our assets look like. This could be layer 2, layer 3, and of course, firewalls. So we're drawing out the map, which is cool, I think, but we wanted to accomplish more with this. So one of the things that we are able to do is not only show you the map and help you draw it the way you want, but also utilize it, for example, if you needed to add an access rule. So a ticket opens and somebody says, I need access from this network to this network or from this host to another using a specific port. How do you know how many layer 3 devices are we going through? How do we know which firewalls and in which CMAs I need to deploy that access rule? So with our dynamic network visibility, you now have the ability to set a source and a destination, and BackBox will illustrate and highlight all those devices in the path that you need to create the access rule on. The next thing before I get to this, just raise of hands. How many are using R77.30 still? Okay, 80.10, 80.20, Firewall 1 3.0b? Nobody? Okay, so with our orchestration, we can actually help you better manage the tasks that you need to perform on these devices. This could be config changes, this could be upgrades, this could be patching. So with this capability, we have the skills to push a single configuration or multiple configurations to hundreds of devices with a single click. That means that if you need to upgrade from one version to another, or if you need to upgrade from one version to another and then deploy a jumbo fix, BackBox can automate that process for you, validating every step of the way and giving you the ability to revert back if anything fails. So for example, in a firewall upgrade, we will automatically upgrade that device. Before doing that, we will verify things like, what was the version, how many interfaces did I have, how many static routes or dynamic routes, and let's say the connection table, what is the average? Following that upgrade, we will recheck those parameters and make sure that they're in line with what we expected. And if anything is wrong within that validation, we will automatically roll back and keep you in the same state. If everything's good, we can move on to the next device. So here's an example of an automation process that we created. This was based on a customer request. So Office 365 is quite a challenge where you need to create too many objects within our rule base in order to support blocking and unblocking of applications within Office 365. So for example, if we want to allow SharePoint and Mail, but we want to block Skype, you would need to create all the Skype objects, right? This could be IPv4, IPv6, FQDNs, etc. So with BackBox, we're automatically connecting to the Microsoft database, could be an XML or an API call, bringing those objects and populating our security database. That means that every time that Microsoft has an update, you won't have an outage because we will automatically update the policy for you. So here's another example. If we want to deploy radius authentication on a checkpoint gateway, or actually on multiple checkpoint gateways, one of the challenges is what happens if I connect to the device, deploy the radius configuration, and something was wrong within that config. For example, the radius server IP, I typed it wrong, I will get blocked out of the device. So with BackBox, when we're automating this time of config, we will connect to the device, deploy the radius configuration, open a new session, validate that we can actually authenticate using a radius server, then commit the change and move on to the next device. If we cannot authenticate, we will roll back. The last thing that I want to talk about before Ted helps me out here is our ability to preemptively check the status and health of your devices and help you comply with your corporate standards. This means that we are monitoring application-specific parameters, such as connection tables and NAT tables and MAC addresses, et cetera, and giving you enough information to prevent downtime before it actually affects your network. So if you're using a monitoring system today, you'll get an up and down situation. With BackBox, you have the ability to foresee a problem and fix it before it actually affects the network. And we're also collecting this information, over time. So you have a way of doing capacity optimization and capacity planning. What does my throughput look like over the last year? How many connections did I have over the last year? And now we can better plan for growth and give us a better way of complying with our corporate standards. So we're just down to 5 minutes. So I'm going to ask Ted to join me, and Ted from Pfizer again, and he's going to talk a little bit about his organization and use of BackBox. Thank you, Ted.
Thank you. Good afternoon, everyone. Thank you for being here at CPX this year. So I'm Ted Czarnecki. I'm a senior manager, lead firewall architect for Pfizer. And Pfizer is one of the top R&D-based pharmaceuticals globally. We were founded in 1849, 120,000 staff, a mix of employees and contractors in 500 locations globally. We have an operation team that spans the globe, and we have 4 major data centers that house our operations. Okay, let's see, there's the green one. First one we're going to talk about is our security architecture. So we have a management platform. It's an HA R8010 Provider 1, and it takes care of 330 gateways globally distributed. Primary hardware is 2016 and 2018 devices consisting of the 23,000 series, 15,000 in clusters, and also we have VSX architecture. First use case we're going to talk about is Provider 1 casualty. So as everyone knows, when you start getting into significant architecture like this with 300 firewalls and the many rule bases and security zones, having an outage of your primary manager can be a catastrophic event. So what we look at is keeping that also protected by the BackBox so that our recovery time, even with the HA, is reduced to a minimum so that we can maintain an HA architecture. So we identify the backup that we want to go back to and do the restore. BackBox verifies it, and then it executes the recovery of the hardware that was brought in for the RMA. Next use case is what we call our security audit. We call it a minimum security baseline. What it does is performs OS level checks of the gateways that verify that certain OS level settings, like no telnet, time references to a GPS and such, are consistent to our standards. And we have this automated every day to test every single device that we have our backups and this process running on. And it presents an email that tells us where we're compliant or not. Thank you.
So thank you, Ted.
Thank you.
So this is the last example that Ted was talking about. So I know we're not taking questions, which is a shame. But one thing I want to mention, or actually 2 things I want to mention because those came up during the breakout. The first one is that everything that we do, all the different procedures, the backup, the recovery, the IntelliChecks that I mentioned, and the tasks are fully customizable. So we have, even though we have thousands of different procedures built into the system, you can customize your own. So within your own environment, if you have different tasks that you need to perform that are outside the box, you can configure them, no scripting needed whatsoever. The second thing, and I think Pfizer is using this as well, is the multi-tenancy and the distributed architecture. BackBox can be deployed in multiple locations and enable multi-tenancy. So if you have different teams and different groups managing different devices, you can segregate the distribution of BackBox and allow individuals to manage their devices and the ones that were assigned to them. So again, thank you very much for having us Checkpoint. Our booth is right in the expo hall. If you have any questions, if you want a demo, if you want a free trial, we are giving away our second Oculus Rift tomorrow afternoon at 3 o'clock. We'd be more than happy to see you there. Thank you very much.
With over 20 years in IT, focusing on security issues, our next speaker has served in roles from administration and operations to CISO. From technical details to executive concerns, he has a wide breadth of experience to share. He is also a man of spirit. That is to say, he's a certified whiskey taster. Ladies and gentlemen, please welcome John Bloomer.
Good afternoon. I know it's been a long day for everybody. We're getting close to wrapping up. So appreciate you taking the time to share with us today. And I wanted to touch base around a concept that I think is pretty interesting and compelling that we don't often think a lot about. And I often ask this question when I go talk to people. And I ask the crowd, what is the cloud? 9 times out of 10, the immediate response I get back is, it's somebody else's computer. And when I hear that response, it really makes me very sad, because if we believe that the cloud is simply somebody else's computer, we treat it like somebody else's computer, and we miss some very interesting opportunities and put ourselves at some very serious risk. So when we start to talk about how we approach the cloud and what the real threat surface looks like, we have to be able to understand, is it actually somebody else's computer, and is it safe to treat it as such? Who is really responsible? How do we deal with those challenges, and are we inviting all the right people to the table? And with great agility comes great responsibility. Spider-Man always agrees with that, but we need to be able to accept the responsibilities that we have to take in order to be able to properly secure the environments that we're facing. And when we talk about the cloud being somebody else's computer, we really put ourselves in a state of denial. It's not my problem. I don't have to take care of it. It's in somebody else's data center. The availability is taken care of for me. All of these things put us in a position where we don't see it, we don't hear it, we don't want to talk about it, because we assume that it's probably going to be okay. But Microsoft research shows that just in the past couple years, we've seen a 300% increase in account attacks leveraged against cloud environments, and it just keeps on growing. Why do we see that? Right? We'll start to talk about some of the ways we look at that, but we have to be able to understand a tremendous shift in the way that we look at how we deploy these things. Typically, we've done a very, very good job of understanding how we secure standard computers, data centers, servers, things like that within our own environments. There's a large amount of data and research available that tells us it's just a bad idea to plug a computer into the internet without any protection. We have statistics on that. Okay? We have it, going back many, many years. The SANS Institute has put together their survival time for a system on the internet. And it's varied up and down. I've seen it go anywhere from 8 minutes all the way up to a couple hours. Right now, current average is about 60 minutes. So we know, as a brick and mortar system, we can plug in and we've got roughly an hour to get all of our patches and security controls put in place before we're likely to have that system compromised and no longer belonging to us. That data really didn't exist for cloud instances until very recently, when our exceptionally talented group of mega ninjas in the security research group decided to stand up a naked system within a cloud environment and deploy a number of tools in order to measure what the actual threat was to this system. Lots of interesting different tools to simulate lots of different systems, right? First and foremost, we've got an SSH and remote access administration console that people can attack. ICS stuff. I can't yell that loud, all right. We've got some ICS stuff. We've got a dynamic Python Elasticsearch, so we can start to appreciate some of the S3 risks. And also a really interesting e-mobility, highly interactive site that's intended to present some of the e-mobility management for electric cars, self-driving cars, things like that, being able to actually interact with user experiences. And so we set all these things out there to be able to understand, once we turn it on, what happens. Right? Standard honeypot methodology. And it was really a little bit shocking. In the first 15 minutes, okay, there were hundreds of events logged on this one system. And so if we look at the survival time of a Windows or a Linux machine being naked on the internet being a matter of hours, in the cloud, it's a matter of minutes. Why is that? Why is it so much faster in the cloud than it is in a brick and mortar system? Well, you've narrowed your inspection set. There are very good automated tools that attackers are using that have the IP ranges, that have the information about the cloud environments that they're out looking for, and they can leverage those to identify new targets as they're stood up and leverage their attacks against them. Now, we talk about the first 15 minutes, and that's a pretty big deal. But really, it wasn't even that long. Within the first 5 minutes, we saw a number of very sophisticated attacks trying to log in via administrative console, brute force SSH, network-based attacks, malware delivery methodologies. So it wasn't like a matter of, oh, it's up, we're going to look at it, we're going to go through this reconnaissance, kill chain, and all of this good stuff. It came up and immediately was under very heavy direct attack. So if the brick and mortar systems need to be protected, the cloud systems probably do too. When we look at protecting these systems, everybody's using great security products, right? You've got the best and brightest out there? Well, we asked. And apparently, roughly a third of people who have a presence in the cloud that responded to our survey assume that their cloud provider is providing them the appropriate protection that they need in order to overcome these kinds of events. Another third thought, I'll get to it sometime later. Okay? So now we've got 2/3 of the companies that are doing business in the cloud have decided that it's either not important enough to take care of now, or somebody else is doing it for me because, right, it's somebody else's computer. Well, it really isn't. And when we start to talk about the fact that it's not really somebody else's computer, now we have to start talking about who's part of the conversation. I like to do a lot of CSO engagement. I do a lot of roundtables and panel discussions and things like that. And I found a really interesting statistic that always kind of wakes some of those guys up when we have these conversations. It was from a report from an automation software company that came out a little earlier this year in the state of DevOps. 2/3 of C-suite individuals or C-suite respondents believe that they have security integrated into their DevOps in a very material and mature way. Roughly 40% of the people who actually do DevOps agreed. So the people that are actually supposed to be integrating into this, DevOps process and the agility of the deployment and things like that don't. But the C-suite thinks they are. So they're assuming that it's taken care of. Okay? When we start talking about having these conversations and getting these people involved, you all are here at a security conference. And I know I've met a lot of you are customers that I deal with on a daily basis. A lot of you are people that I known for quite some time. How many of you invited your DevOps team to join you at this conference? How many of you thought that they might get some value out of having the conversations that you're hearing about while we're here today? So it's going to become very, very important as the cloud adoption accelerates that we get the right people involved in the conversation to then move it forward. But cloud risks aren't limited strictly to offensive attacks. We're not looking at just people beating on the doors and trying to knock down your walls and get into your systems and leverage your the compute that you're paying for to mine currency. But we can really do it to ourselves. I love the term mindless data sharing because it really does happen, and it's a totally DIY kind of compromise. Until very recently, AWS, S3, right, elastic storage, was designed around the notion of making data files available on demand for interaction within applications, and the default setting for any newly created S3 bucket was to allow public access. Seems harmless enough until we start seeing that you've got insurance records being put out there, medical records put out there, proprietary information being put out there, without anybody doing the actual inspection to see what were the default permissions and should I have protected them. Now, we would think we've done a very good job about fixing this. That default setting is no longer there. You actually have to change it in order to expose the bucket. But anything that was built before that default setting hasn't been reverted. So there's still a lot of stuff out there. And there are websites dedicated to documenting and cataloging all of the files that are exposed in public S3 buckets. So as of last week, there were roughly 50,000 exposed S3 buckets with 20 million files available to view and download. And that's 20 million files available to download with a lot of the garbage filtered out. So there's no graphics files like GIFs and JPEGs and stuff like that. They rip all that out because nobody cares. That's mostly PDFs, Excel files, Word docs, stuff like that. That's really meaty and juicy. And as I was looking for some statistics on how often this sort of things happen, I saw a lot from a year or so ago, and I thought, well, maybe this isn't that big a deal. But then last week, we see another instance where 24 million loan records exposed in an Amazon S3 bucket. Last week. Haven't we learned our lesson? Do we need to really hack ourselves? Isn't it enough that other people are trying to do it for us? And the other part of this is it's not always just about what you do, it's about what the people you do business with do. Many of the disclosures that happened from S3 buckets weren't a direct result of somebody misconfiguring their S3. It was their business partners that they had applications to integrate with that shared the data that they had. One of the biggest insurance breaches ever that happened last year was business affiliates that stored private data in S3 buckets that were exposed for the insurance processors to access and do what they needed to do that forgot to set it as not publicly accessible. So we really need to be able to admit the fact that sometimes good enough simply isn't. Native controls aren't going to get you from where you are to where you want to be. Okay? If you always do what you've always done, you always get what you've always got. And you have to be able to take that next step to really be able to elevate your security posture to a more mature level where it's not somebody else's computer, somebody else's problem. You take ownership and responsibility for what it is that you're actually putting out there. You protect it, and you protect your business partners from the exposure of the elasticity that the cloud offers. You take advantage of the opportunities, but you also invest in the costs to have the availability and protection. Once you can admit and you can really answer the question, what is the cloud? And not say it's just somebody else's computer, you've taken a tremendous step forward. Okay? You've done yourself, your company, your organization a tremendous service in enabling and empowering your security practice to really enable it to move to the cloud at a pace that the cloud demands, the pace of business, the pace of application development. And you need to be able to get the right people at the table to have the conversations in order to be able to flow that mindset all the way down to the bottom level. Get the DevOps people involved. We say DevSecOps all the time, and often they're snickering behind their hand like, yeah, right, that's happening. Get them involved. Have them at a seat at the table. Invite them here. Invite them to the people that you talk to about security and security challenges in order to make sure that they know and understand the things that you're trying to protect them against and your customers and your clients against so that they can be part of the solution and not always contributing to the problem. And you need to be able to understand your responsibility. Okay? There's two key things that we see and when we move to the cloud, and it's often baffling to me how few people seem to be familiar with the shared responsibility model. It's something that we've thrown up on slides for the past year or two, trying to articulate where the separation of duties is. And anytime you've got somebody that wants to throw something out there and say it's somebody else's computer, it's somebody else's problem, has willfully disregarded the shared responsibility model and put everybody else and all of those systems at some fairly grave risk. So I'll leave you with one key thought. If you've got a presence in the cloud, if you're working in the cloud and you've got a DevOps team and you're putting your workloads out there, and something were to happen today, would you have the tool sets? Would you have the talent? Would you have the mindset to actually know that something happened, how it happened, when it happened, and how you might recover from it? Visibility and security go hand in hand all day long. And if it's not just somebody else's computer, then you must have that visibility to measure what it is and how you protect it. I appreciate your time today. I invite you to connect with me. You can follow me on social media. And without further ado, I will get off the stage and we'll have what most people are actually waiting for, and it's Dorit Door, which is everybody's favorite part. So thank you very much. I look forward to seeing all of you later. Thank you.